that much of the decision-making in healthcare is a function of either guesswork or experience or gut. And we think that as we learn more and more about the human genome, that the answers are going to become more precise and the cures will then follow. The genomic revolution is going to change healthcare as we know it, partly because it's deflationary. The healthcare sector has never experienced the good kind of deflation. All healthcare analysts know about deflation is patent cliffs, and that's really, really bad. Technology usually brings with it good deflation. And so what we're seeing from DNA sequencing is costs falling about 30 to 40% per year. And we see the first human genome was sequenced for a cost of almost $3 billion and took 13 years of computing power. We're now down to, well, less than $1,000 per human genome in a day or so. And by 2021, we think we'll be at $100, so that DNA sequencing will become part of our annual physicals. And DNA sequencing will be able to identify where our genes have mutated and why we have certain kinds of diseases. We're also, with CRISPR technology and CAR-T technology, going to learn about ways of actually curing disease. CRISPR technology, CRISPR-Cas9 specifically, is gene editing. Now, gene editing is really not new. We had a gene editing technology called zinc finger nuclease, and that has achieved some success, but it's extremely expensive, about $5,500 per base pair of DNA that's edited. Today, CRISPR-Cas9 can edit at $30 per base pair, so a huge drop in the costs. Gene editing is exactly what it says, editing. It's cutting, activating, silencing, regulating. We call it the molecular Swiss Army knife. In essence, gene editing can reprogram the mutations in our DNA. Our DNA starts out usually just fine, and then mutations happen along the way, and now we have a technology that can edit them away. To give you a sense of how important this is, only 5% of the monogenic diseases, so the diseases caused by one gene, only 5% of them are treatable today. With gene editing, all of them potentially will be treatable. And then beyond that, monogenic is only 2% of all the genes out there. So if I were to tell you that if we were able to solve all the problems for people with monogenic disease, that's a $2 trillion opportunity, can you imagine how big the polygenic opportunity is going to be? This is really one of the most exciting investment ideas we have ever experienced.